Welcome back. Now that you've seen the analogy of JSON, let's look at JSON real quick to get a little better understanding of what it is about. So you have the general idea now with the advantages and all of that, but let's look at what JSON actually stands for. So it stands for JavaScript Object Notation. So that's what the name comes from. While it was originally used in JavaScript, now it's used all over the place. And it's a lightweight data interchange format, pretty much what our story told us, right? So JSON is a standard text-based format for representing structured data based on JavaScript object syntax. It is commonly used for transmitting data in web applications. For example, sending data from the server to the client so it can be displayed on a web page or vice versa. And in our case, it's not going to be to a web page or displayed on a web page, but actually on our phone, and we're going to load that data. So is JSON a programming language? No, it's lightweight text-based language-dependent data interchange format. So it's not really a programming language, but it was derived from JavaScript. Then when to use YAML versus JSON, that's not relevant. Well, this one I want to quickly go over, JSON versus XML, because XML is another way to store data very efficiently and store it in a way so that it can be transferred very easily and lightweight and all of that stuff. JSON is just even more lightweight and it's also super easy to read. And XML basically has a bracket for every single thing where for every single object, every single property and so forth. And it's just a different way to send data around. And you might sometimes get data in the format of XML, but that is more of a thing of the past. So more or less everyone is now using JSON, you could say. So in case you ever need to use XML, you'll need to figure out how to make small adjustments to your code, but usually JSON really does the trick. And in most cases, JSON will just be the format that will be used. Now let's go over to the JSON website. Now JSON was built or is built on two structures. One is a collection of name value pairs. And there are different ways how you can have a name value pair. For example, you can have objects, records, structs, dictionaries, hash tables, keyed lists, or associative arrays. So we have not seen any of these keywords or not used any of these keywords. And the only thing that we did use is object itself. So that is fine because other elements here that you can see, they are from other languages. So record, for example, is used in C# since C# 11. Struct is something that is used in multiple different languages. Then dictionary is something that is also used in multiple different languages. Basically an association between one keyword and a content piece. Okay, and that is what we basically have inside of our objects as well. So we have a property, and associated to that property we have a value of that property. For example, name has the key name and the value of whatever a name is associated to the property of name. And hash tables are for Java, I believe, and I don't even know like where keyed lists or associative arrays are used, but basically it just says, okay, these are the types of key value pairs or name value pairs that are built into JSON. And the other one is an ordered list of values. So in most languages realized as an array, vector, list, or sequence. So in our case, in the case of Kotlin, we're talking about lists. So list of is basically the ordered list that we can share save inside of JSON. So how is that structured? Well, objects are structured within curly brackets, as you can see here, and lists are structured inside of squared brackets. That's pretty much the logic. And we're going to see how that is structured in our own examples or in a few examples in the next videos. So that was just to give you a very small overview. You can read through this page, but again, you will probably come out more confused than you came in. And that is why I'm not going to go into too much depth into what this introduction does, because it just throws around so many words trying to please everyone, and that just doesn't work. So let's rather use it and understand it through that than go through a way too overcomplicated page. Now, obviously the graphs here, they help you a little bit, but then you need a lot of background information to understand what all of this stuff does. Okay, so see you in the next video.